Okay, we're on to combining functions. There are, I guess, 4 different ways of combining functions. If you have 2 functions, f of x and g of x, when they ask you this, well, this has no meaning yet. We're going to define what that is. And when you say you're defining something, you use 3 lines. If the left side has no meaning yet, the left side, this, is defined to be f of x plus g of x. That's what it means. Add the 2 functions. So for example, if f of x was 3x squared plus 4, and g of x was 7x cubed plus 9x, if somebody asks you to find f plus g of x, well, if you add the left side, if you add this, you get f plus g of x. That's how it was defined. And when you add the right-hand side, you get 7x cubed in order, if I write it, if you don't mind. You get this. Just added them. I just added them. If I tell you f of x is 3x squared plus 7x plus 9, and I tell you that g of x is 4x squared minus 2x minus 3, well, if you add the left sides, so if somebody asks you to find this, they say, if f equals this, and g of x equals that, find f plus g of x. Okay, that's the question. Well, f plus g of x, by definition, is f of x plus g of x. So I add them. I can add those. Those are like terms. I'll get 7x squared. I'll add these. I will get plus 5x. And not positive 9 minus 3. I can add those. And I'll get 6. And there's my answer. Just add. What if you're not given f plus g? What if you're given f minus g of x? Given f minus g. Well, it's defined very similarly. Instead of f plus g, it's f minus g. Now, instead of adding the 2 functions, you subtract them. You subtract them. If I tell you, so here's a question underneath. If f of x equals 3x squared plus 4 and g of x equals 7x cubed plus 9, find f minus g of x. Well, f minus g of x, by definition, is nothing more than f of x minus g of x. That is, it's f of x minus g of x. So I see cube terms, I see square terms, I see linear terms, that is x terms, see constants. 0x cubed minus 7x cubed is minus 7x cubed. I'm subtracting. 3x squares minus no x squares is still positive 3x squared. 0x's minus 9x's is negative 9x. Constant is 4 minus, and understood 0 is 4. And there's the answer. Okay, you subtract them. You subtract them. One function minus the other function. if instead of times, if instead of subtraction, we have a dot in between. I'm at the very top now. If we have f dot g of x, that just means the times. It means this times that. That's all it means. So, if you're given those same two functions, and they ask you to find f dot g of x, it's pretty simple. F dot g of x, by definition, is f of x times that times g of x. That is, it's f of x times g of x. Okay, if you want to, you distribute that out. If instead of dot, if it had a slash, that is division, you divide the two. You divide. That is f over g of x is f of x divided by g of x. But this is providing g of x is not 0. You can't divide by 0. That's the only thing. So here, find f over g of x. All you do is divide. That is, the answer is f of x over g of x. You divide. Okay? So again, when there's a plus in between the two functions, you add the two functions. If there's a minus between the two functions, keep in the same order, that is f first, and then g, you subtract. Only because f is first and g was first. If you have a dot in between, you multiply. This means f of x times g of x. If there's a division in between, well then this is f of x over g of x. You divide the two. Now, what if we want to find the domain of these combination functions? What if I tell you f of x is equal to 1 over 2x and g of x is 3x squared plus 4x minus 1 over 2x. Okay, so we want to find the domain of f plus g of x. I will call this in the future the domain, D for domain, of f plus g. What is the domain of f plus g? Now, it is not good advice. It is not good advice to calculate f plus g of x. Because if you do that, f of x is 1 over 2x plus 3x squared plus 4x minus 1 over 2x. This cancels and you get 3x squared plus 4x. Now, one may think that these two are equal? One might think that those two are equal. For example, if you were asked to find f plus g of 4, you might think, and sometimes you'd be right, that this is 3 times 4 squared plus 4 times 4. This is 16, this is 16, so we have 4 16s. I factored out to 16. Okay, it's 64. And in this case, it's correct. Now, let's be sure. Maybe we're making a mistake. It's supposed to be f of 4 plus g of 4. Well, f of 4 is 1 over 2 times 4, plus g of 4 is 3 times 4 squared, plus 4 times 4 minus 1 over 2 times 4. And coincidentally, that cancels out, and we have just what we have right here. We have 3 times 4 squared plus 4 times 4. 64. They are correct. The thing is, will this always be correct? And, okay, it's too late. What if I plug in 0? What if I plug in 0? So, using our f plus g of x rule, we get 3 times 0 squared plus 4 times 0. Well, this is 3 times 0, or 0, and this is 4 times 0, or 0. 0 plus 0 is 0. But here's where we come into trouble. If you look at f plus g of x, by definition, or of 0, by definition, if f is 0, plus g is 0. But you know what? After 0 is this. It's 1 over 0. It doesn't make sense. And g of x, although maybe part of it may make sense, I don't know what 1 over 2 times 0 is. That is, both of these are nonsense. I can't add the nonsense, and I definitely can cross that out. That is, f plus g of 0 is undefined. Okay, that is, we can't let x be 0. Now, why does it seem like it worked? Why does it seem like it worked? Because the troubled area canceled out. 1 over 2x minus 1 over 2x, we claimed was 0. That's not true if x is 0. All right. So, we talked in great detail of how not to do this. That is, if somebody asks you for the domain, you do not compute, you do not combine the functions and simplify. You do not do that. F, to calculate or compute f plus g of x, we must calculate f of x, and then we must calculate g of x, and then add them. All right. Now, if you want to find the domain of the left side, it's going to equal the domain of the right side. That is, what can we not take f of? Well, you can't take f for 0. You can't divide by 0. So what we're taking f of, namely x, cannot be 0. What can g not be? Excuse me, x. We're taking g of x. Whatever it says in the brackets, I write it down. What can't go in between the brackets? Well, again, you can, well, not again, you can square any number, including 0, and then multiply it by 3. You can take any number and multiply it by 4. Any number. And then you can add them. The thing is you can take away any number, but that number has to make sense. When x is 0, it makes no sense. It makes sense. But then you're taking away something that's nonsense. x can't be 0. Combining these two comments, you have that the domain of f plus g is x is not 0. You cannot take f plus g as 0. Alright, let's try another one. So you have f of x is equal to the square root of x minus 2, and g of x is 4 over x minus 7. Okay, find the domain of f minus g. Do not find f minus g. That will not work many times. This equals f of x minus g of x. Well, we need to find f for something. What do you find? Remember, what goes underneath here cannot be negative. That is, the domain of f, getting it from right up there. The domain of f is what's underneath the parentheses have to be 0 or more. That is, x has to be greater than 0. That is, what I put in here has to be greater than or equal to 0. I'm putting x in there. X must be greater than or equal to 0. Now, let's find the domain of g. You can't divide by 0. That's it. You can't divide by 0. X minus 7 cannot be 0. That is, x cannot be 7. X cannot be 7. Okay? And here pretty much is your answer. The domain of f minus g is such that x is 0 or more and x is not 7. You wanted to put this on a number line. X can be 0 and above, except 7. That is, at 7, open circle. At 7, open circle. And that's your domain. This is your domain, I guess, algebraically. Here is your domain using a number line. If you had to write the domain using interval notation, the domain of f minus g. Well, first you can be in that interval. X can be in between 0 and 7. It can equal 0. That's why it's filled in. It even says it can equal 0. But it can't be 7. The other piece are these numbers. Union. These numbers all have one property. They're all more than 7. And that's another way of writing the domain. Okay, it depends upon your instructor and textbook, how you write your answer. Do not find what f minus g of x is, because the problem area might cancel out. For example, if you have f of x is equal to 1 over x, and g of x is equal to x squared. Find the domain of fg. Find the domain of f times g. Find. Okay. Well, f times g of x, by definition, is f of x times g of x. You should stop there. But if you continued, you'll get f of x, 1 over x, times g of x, x squared, which is x. So now you're going to say f times g of x is x. That is, you can plug any number in there. F times g of 2/3 is 2/3. It's the identity function, it turned out. Whatever intelligent number you put in there, you'll get back an intelligent number. That is, the domain is everything, it seems. It seems. Because the problem is, what's the domain of f times g? The problem comes right here. What can you not, if anything, take f of? That is, what is the domain of f? Well, the denominator cannot be 0. That is, x can't be 0. What we're plugging in here can't be 0. Now, the domain of g is all real numbers. You can square any number. Okay? That is, we're removing nothing. We're removing nothing. Empty thing. So the domain is just x is not 0. That is your answer. Now, let's look at this for a moment. I'm claiming that f times g of x is x. Now, this is not exactly true. You need to say, include the domain if x is not 0. Now, it's true. That is, fg of any number, as long as that number is not 0, is itself. F times g of 7. I claim it's 7. That is, it's f for 7 times g of 7. But f for 7 is 1 over 7 times g of 7 is 7 squared. Well, that's 7. It just doesn't work with 0. Don't calculate the combination of the functions. Don't do it. Unless you're asked to do that as well. Okay, unless you're asked to do it, don't do it. That is part A, find out what f plus g of x equals. Part B, find out the domain. Well, then you have to do both. Okay, for example, suppose you have f of x is 1 over x plus 1, and g of x is x over x plus 1. And you want to find A. F plus g of x, and B, the domain of f plus g. Okay, well, to find f plus g of x, we know that, so doing part A, this is f of x plus g of x, which is 1 over x plus 1 plus x over x plus 1. Since the denominators are the same, I keep it in addition, and I add the tops, 1 plus x. Where 1 plus x is, of course, the same as x plus 1. That is, I always get 1. Now, I claim this answer is not done yet, because you have to find the domain. The domain of f plus g may not be the domain of f plus the domain of g. Okay, the domain. So, the domain, you look at this part. What's the domain of f? That is, what can you not put in there? Well, you can't divide by 0. X plus 1 cannot be 0. Bring the 1 over, x cannot be negative 1. So what I'm putting in there, it can't be negative 1. Now let's go to G. Because I see G here. I'm taking G of something. What can you not take G of? Well, G has the same problem. The denominator cannot be 0. That is, x cannot be negative 1. And x cannot be negative 1. Well, how many times can they say it? The domain of f plus g is x cannot be negative 1. In my opinion, A is not finished yet. It equals 1 if x is not negative 1. Because if I claim that f plus g of x, what I have to the left equals 1, then I have a problem. I mean, yeah, f plus g of 13 is 1. But f plus g of negative 1, or f plus g of negative 13 is 1. But when you plug this in, you also get 1, which is wrong. Okay, it's wrong if you just say it's 1. Now, why is f plus g of negative 13 13? Because f for 13 is 1 over 13 plus 1 plus or negative 13. And g of negative 13 is negative 13 over negative 13 plus 1. The denominators are both negative 12. Add the numerators. 1 plus negative 13 is negative 12, which is 1. F plus g of negative 13 is 1. Alright, so to find a domain, do not combine the functions first. Do not. Now, I will make a comment that if we have a okay, let's just go to another page. This won't help you do any of the problems, but if you do it this way, whatever you get will not be wrong. You just won't have all the answers. If after calculating, say after calculating f plus g of x, you get something like 1 over x plus 1 or 4 over x plus 1, this has a restriction, negative 1. X can't be negative 1. Well, if you would have computed the domain of f of x as well as the domain of g of x, one of them would have said you can't let x be negative 1. That is, if you do have this here, the domain of that will always be included in the domain of this. Okay, that is, if you quote do it wrong, if you just come to here, you may miss out other bad points, but whatever bad points you do find will be correct. But in the end, don't find the domain of combination functions by combining first. You cannot do that. Okay. Now we have another type of function that can be combined. They're called composite functions. If instead of a dot you have a circle, f circle g of x, this is defined to be f of g of x. So, example. Suppose f of x is 2x plus 1, and g of x is 3x minus 2. you were asked to find f circle g of x, by definition, this is f of g of x. First thing is, plug in what g of x is. It's given to be that. Okay. What is, and here's the rule right here. What does f do to what you put in the brackets? And in defining a function, you put a simple thing in the brackets, like x. You want to put 7x plus 20. Too complicated. What's being done to x on the right side is being multiplied by 2, and then we add 1 to it. That is, whatever, x is a dummy variable. Whatever you plug between the brackets, in this case x, what does f do to it? It multiplies it by 2 and adds 1. Regardless of what goes in the brackets, and here's what's in between the brackets of f, whatever goes in the brackets, you multiply by 2, and you add 1. And then you get 6x minus 4 plus 1, or 6x take away 3. Of course, there's no reason why you can't. So this is, for obvious reasons, this is called the FOG function. FOG is FOG. This function is called the GOF function. Somebody asked you what this is. Well, by definition, it means g of f of x. Notice the order of the letters never change. G, f, and then x. G, f, and then x. F, G, x. F, G, x. So this is g of f of x. And f of x is still 2x plus 1. Same functions as before. Same two functions. Now, what does g do to x? What does g do to x? It multiplies by 3, takes away 2. What does g do to what's in the brackets? It multiplies by 3 and takes away 2. So g of this. I'm going to take this. I'm going to denote I'm multiplying it by 3, taking away 2. And we get 6x plus 3 minus 2, 6x plus 1. But I should state the domain. Maybe x can't be 4, for example. But that's coming up. Now, you can have other functions, like maybe f circle f of x. Well, this is f of x. F of x happens to be 2x plus 1. What does f do to what's in the brackets? It takes what's in the brackets, multiplies it by 2, and then adds 1. So you have 4x plus 2, 4x plus 2, plus 1 more, 4x plus 3. And that's what you get for the f circle f function. Now, let's talk about domains of these things. Again, do not calculate the composite functions and then find the domain of that answer. Don't do it that way. It's wrong. If f of x is 1 over x minus 2, and g of x is 1 over x, find the domain of g circle f and the domain of g circle g. That's part A. And part B is find g circle f of x and g circle g of x. Alright, so now let's do part A. A and B together. Let's find the domain of this and what it equals. Well, by definition, this is g of f of x. And f of x is 1 over x minus 2. And g takes the reciprocal. That's the job of g. Whatever you put in there, out comes the reciprocal. The reciprocal of 1 over x minus 2 is x minus 2. Okay. Now, let's be careful about finding their domain. What is the domain of G circle f? Well, we are taking f for something. That something happens to be x. What can you not take f of? What can you not take f of? You cannot plug in 2. In here, you can't plug 2, because then you'll get 1 over 0. So what I'm taking f of, namely x, it cannot be 2. Okay. What? Now, okay, what are you taking? Now you're taking g of something. You're taking g of this. You're taking g of 1 over x minus 2. What can it not be? It has nothing to do with 1 over x minus 2. It has to do with what you can and cannot take g of. You can't take the reciprocal of 0. That is, that cannot be 0. But will it ever be 0? Will it ever be 0? A fraction is 0 when the top is 0 and the bottom is not. That's 0. Our top is always 1 and the bottom is whatever. It doesn't matter what the bottom is. This will never equal 0. Because I don't care what you plug in for x. When you take away 2 and you multiply it by 0, you'll get 0, which is never 1. So this will never happen. So the only thing is that survived is x cannot be 2. X cannot be 2. That's the domain. Okay? So back in the function, you should say GOP of x is equal to x minus 2, but x can't be 2. X cannot be 2. Alright. That's half of the problem. Let's do the same problem with the GOG function, G circle G. Well, G circle G of x, by definition, is G of x. But G of x is 1 over x. It says so right there. And what does G do to what's in there? It takes the reciprocal. So that's almost our answer to part A. Because there might be a constraint. Now for part B, for the domain of G circle G. Well, we're taking G of something. If something happens to be x, what can you not take G of? Well, you can't let the denominator be 0. That is, what you plug in there goes in the bottom. It can't be 0. Okay. Now, you're taking G of something else. What you're taking G of is this. And that can't be 0. But you know what? This is never 0. This will never happen. You'll never be taking G of 0. Because G of x is never 0. 1 divided by x can never be 0. Because the top is 1. So the only constraint is x cannot be 0. Alright, let's do one more where you can have constraints in both cases. suppose I said that f of x is 1 over x minus 2, and g of x is 1 over x plus 1. And we want to find the domain of f circle g. So, f circle g of x, by definition, is f of g of x. Okay. Now, this is where we stop. We're taking g of something. That something happens to be x. What can you not take g of? The bottom cannot be 0. That is, I meant to say g. So x cannot be negative 1. What goes in here cannot be negative 1. X is going in there. It can't be negative 1. Okay, now we're taking f of this. What can you not take f of? You cannot take f of 2. What you're taking f of can't be 2, because that's what makes the bottom 0. We're taking f of this. It can't be 2. It can't be 2. That is, 1 over x plus 1 cannot be 2, which, by the way, is the same as 2 over 1. The easiest way to solve this is to take reciprocals. So I want x in the numerator. The reciprocal of that is just x plus 1. The reciprocal of the other side is a half. Take away 1 from both sides, you get that x cannot be negative a half. So we have these two values that x cannot be. The domain of f circle g is x cannot be negative 1 and x cannot be negative a half. Now, if in addition they ask us to find fog of x, well, it's f of g of x is x plus 1. All right. Now, what does f do in words? What does f do to what goes in the brackets? Well, first, it puts it in the denominator, and it takes away 2. And it puts a 1 on the top. Multiplying each of these terms by x plus 1, we get x plus 1 over 1 minus 2x plus 2, which is x plus 1 over negative 1 minus 2x, which is x plus 1 over 1 plus 2x with a minus in front. Now, that's what fog of x equals, but you need to say that x cannot be negative 1 or x cannot be negative a half. Now, when it comes to negative a half, that's going to make this 0 anyways. And that won't be allowed. So you don't even really have to state that. It's understood. Because if you plug negative a half in, you'll get negative a half over 0, which is undefined. But if you plug 1 in, if you plug in negative 1, you get 0. But you really don't. It's undefined in negative 1. Before you find the domain, in order to find the domain of combination of functions or composite functions, do not combine the function till the end. Do not. Okay, because if you do that, you might come up with erroneous answers. Okay, good luck with this.